It's you and me, 11.10, normal distribution. Why is normal distribution important? It's what you guys are most familiar with as the typical bell curve. And so when we analyze data, we usually put it onto graph and then see how the bell works. And so the normal distribution is what we're dealing with when we're doing the bell curve. Here it is. Here's an example of how to read a normal distributed bell curve. Here we have the number of heads from 20 coin tosses, and then the percentages as to when they happen. So when the question is asking about what percent of the coin tosses land heads 8 times, all you got to do is look at the 8 times that it lands heads, and the chart goes over, and it looks like it's at 0.12, otherwise known as 12%. About what percent of the coin tosses land heads at least 13 times? All right, so the wording is important. At least 13 times. That means 13 or more. And I know 13 is not written there, but right there is 13. So at least 13 means 13 or more. So basically all of these. All right, so we're going to look at the percentage for 13, and it looks like it's at 7. It's in between 6 and 8, so 7. And then we're going to look at this percentage, which if we go all the way across, looks like it's 4. And then we're going to look at this one all the way across, and it looks like it's at 2. And then this one's super small, so I don't think we even have to count it because it's so small. Oh, I did count it. It's 1%. And so you do the 7, the 4, the 2, the 1%, add them all up, and that is approximately 14%. All right? So at least 13 times means all of these together. All right? One more question on this chart. Let me clean it up a little bit. What percent of head coin tosses fall within 1 standard deviation from the mean? All right, so here is when we have to, oh, I gave you the answer, but let's look at how I got the answer. All right, so here's when we look at the information that's given up here. Remember, X bar stands for the mean, the average, and then this lowercase sigma is the standard deviation. All right, so the mean is 10. So it's right in the middle, it's 10. And then every time you move 2 units up and 2 units down, that's considered 1 standard deviation. All right? And so the question is, what percent of head coin tosses fall within 1 standard deviation of the mean? And so basically from 10 to 12 is considered 1 standard deviation away. And from 10 to 8 is also 1 standard deviation away. All right, so we're looking at this amount of data. So we have to look at this first piece, which is the 12. The next one over, which is 16, the very top, 18. This one is also 16, and this one is 12. So all of these guys fall within 1 standard deviation away. And so that's how I got those numbers. Add them up, it's about 74%. All right. Moving on. Percentages of normal distribution. All right, so this is the percentages for when we ever do normal distribution. Here, right in the middle, is called the mean. And then this is 1 standard deviation forward and 1 standard deviation backwards. each way is going to be worth 34%. Okay, and that's going to be always. Whenever I talk about normal distribution, the one standard deviation away is always going to be 34% above and 34% below. When you go 2 standard deviations away plus 2 SD, we are now talking about 13.5% up and 13.5% down. And again, that's always going to be the case. And then if we go 3 standard deviations away, it says it's 2.35, but we're actually going to put those two together. So the 2.35 and the 0.15, we're going to put them together to make 2.5. Same thing on this side. These guys, because this is so small that we're going to just lump them in together with this one to get 2.5. And that's going to give you 3 standard deviations away. All right, let's do an example. Sketch a normal distribution curve with 1, 2, and 3 standard deviations given that the mean is 50 and the standard deviation is 3. All right, so we have a number line. First thing we do, we're going to go ahead and graph the mean, the average, 50, right in the middle. All right. That's going to be represented by 34% forward and 34% backwards. All right. 1 standard deviation away gets you at 53. Remember, standard deviation was 3. So up 3 and down 3. That is called 1 standard deviation. Next part, it's about 13.5%. If we go 3 more up, it's at 56. 3 more down, it's at 44. That is now 2 standard deviations away. And then the last part, the 2.5%, if we go 1 more up, we end at 59. 1 more down, we end at 41. And that is called 3 standard deviations away. So 1 standard deviation, 2 standard deviations, 3 standard deviations away. Okay, so that's how you draw it out. And it looks like it makes a little bell curve. Something like that. All right, let's do another example. The heights of American adult males are approximately normally distributed with a mean of 69.5 inches and a standard deviation of 2.5 inches. We're going to go ahead and sketch the graph. Here's our number line. First thing you do is you're going to graph the mean right in the middle, 69.5. Go 1 forward, and that's going to be at 72 because 1 standard deviation away, you just add 2.5 up and 2.5 down. That is called 1 standard deviation away. Let's go ahead and do 2 standard deviations away. So add another 2.5 to both sides. And that is 2 standard deviations away. And then 3 standard deviations away gets you to 77 and 62. And that's worth 2.5% either side. All right, so there's our sketch. Start with the mean and then just add both ways the standard deviation. Next question. All right, using the same problem, the next question is what percent are between 67 inches and 74.5 inches? Okay, so we just have to look. Where is 67 inches? Right here. Where is 74.5? Right here. So we want to know what percent is in between there. And so it's all these percentages, the 34, the 34, and the 13.5. And we have about 81.5%. All right, final question. In a group of 2,000 males, how many would you expect to be taller than 6 feet? Well, you should know that 6 feet if you convert it to inches, 6 times 12 is 72. So what percentage of the males is going to be taller than 72? Just add those two percentages up and multiply it by the 2,000, and about 320 males out of the 2,000 will be taller than 6 feet. All right, that's all we got. Go ahead, try the homework, see how you do.